Hello everyone, this is BritJet's PSX Tips, the Aerowings PSX 747 desktop simulation, and today I'm continuing my videos with a chat about descent planning and configuration changes when to start dangling your dangly bits. So let's see what we can find. So descent planning is a bit of a dark art. It's largely guesstimation, but if we take into account as many of the variables as we can, things are going to get a lot easier. As a general guide, if you start your descent with 3 times your height plus 15 miles from destination, so 30,000 feet would be 90, plus 15 would be 105. Something like that will get you in the right direction. Descent speed, probably not a good idea to descend at faster than 300 knots initially as a plan. You might need to increase the speed later if you get high, and if you're already going fast it makes life rather difficult. The FMS will take account of all kinds of factors such as the weight of the aircraft, headwind, tailwind component and so on, as we know. But it is a case of rubbish in and rubbish out. So let's just have a look at the descent forecast page on the FMS and see what we can do to prepare for our descent. On the descent page, check the speed the aircraft is going to descend at, particularly if you've been using econ speed with a high cost index. This speed could be very high indeed, so always have a look at that and amend it if you feel you need to. If we move on to the forecast page, a couple of points there. Transition level 60 here. Just be a little bit careful here if there is high pressure at your destination. If you suddenly change the QNH setting and you wind it to something like 1030, you'll find you're suddenly several hundred feet higher than you thought you were. Always worth bearing in mind if the transition level is quite low. Towards the right there, thermal anti-icing on altitude. The altitude at which you can expect the nacelle anti-icing to come on. When the nacelle anti-icing activates, the engines spool up slightly. It's not a lot, but it's enough to shallow out the descent to a significant amount, and it's worth possibly putting in there an altitude at which you think you might be entering icing conditions. The winds and the altitudes below that, obviously have a look at those, make sure they're sensible. I've put them in calm for the purposes of our exercise today. Gates. What are gates? Well, in addition to the FMC stuff that we've got, we want to actually also have some gates. So let's think about what... Sorry, wrong gates. There we go. Gates. Have 2 or 3 gates in mind on your approach. These are points in space at which you want to hit with a certain speed, a certain configuration. The standard ones, which I will offer to you, would be this one, 35 miles, 10,000 feet, 250 knots. That's a really good starter for 10, and that would be at sea level in normal standard conditions at 250 tons. Obviously, if you're not at sea level, the aircraft will have a higher true airspeed. If it's hotter, the air will be thinner, same deal, and the aircraft will be heavier or lighter than that. It will have an effect, as we'll see later, but that is a really good one to go for. When you get a bit closer to the airfield, try this one. 20 miles from the airfield at 6,000 feet, just coming back to the up bug. You don't have to be on the glide slope at this point. However, when you get to about 10 miles, you really need to be thinking about being on a 3-degree path with the flaps getting down to about 10. So those 3 gates are really quite useful. You can invent your own depending on what sort of approach you've got. If it's an RNAV approach, you pick up a fix or something and you want to be at a certain speed and altitude there. But always have in mind gates such as those. A heavier aircraft will glide further, so we have to take that into account. It seems to fly in the face of physics, but the little diagram here might help. The lift vector is angled slightly forwards in a descent because the nose is pointing down and the lift is right angles to the wing. Now that forward pointing gives you effectively a little bit of a tailwind. And the more lift you've got, in other words the heavier the aircraft, then the more that effective tailwind becomes. So a heavier aircraft will glide further, and you have to allow for that. Okay, that's enough chalk and talk. Let's do a little bit of flying. Here we are, 10,000 feet, frozen in space on the approach, 35 miles. The aircraft is at 250 tons, and we will start a descent just to see how things work out. On our way then. In flight level change, you'll see the VNAV pointer is showing we're about 1,000 feet low. It's just a different calculation to the one we're using, which is our 35 mile and 20 mile gates. One thing I'll point out here is the effect of engine anti-ice. So if I switch that on now, watch the settings on the upper ICAS, you'll see that the engine's throttle up a little bit, like that. Now that will flatten your approach, has to be taken into account. We don't need it today. I'm going to switch it off. Another thing you might look at is to see if you've got any head or tailwind on the way in. Progress page 2 is a good way of looking at it. At the moment we've got an abeam wind, so it's fine at the moment. So we're carrying on down to our next gate, which is 6,000 feet, coming back to the up bug. So let's talk again when we get there. Approaching 6,000 feet now, 22 miles, so I'm going to start bringing the speed back now. Now as soon as you do that, of course, that will flatten out the glide angle as the aircraft decelerates. Not a big problem. You can go above the glide path angle. You will recover it later on once the speed comes back, so no need to panic. We're now thinking, as we get to 20 miles, that what we need to do is start configuring the aircraft. So I'll go to flap 1. Now if you're putting flaps down, don't use them as speed brakes. Just put the flaps down with about 10 to 15 knots above the limit speed, and then wind the speed back to the next bug. So for example, if I want to go to flap 5, which will be my next step, I would start to select flap 5 about now, and then wind the speed back to the 5 bug. If you do need to increase the rate of descent for any reason, speed brakes is the thing to use, and if it's really dire, the gear, provided you're not going too fast. So the speed's coming back. You'll see we are above the glide slope very slightly, but the aircraft is under control, and once you've got that flap 5 down, you are solid gold really, because that's the bit that sometimes can cause a bit of an issue. So our next a bit of an issue because it takes so long for the flaps to run down. So our next target would be 10 miles, and we're looking to be 3,000 feet there. Now if you look at the profile now, the top left there, this comes from the analysis section of PSX. You'll see there's a magenta line which points out the glide slope. Now that magenta line, we are slightly above it at the moment, but you'll see we're nicely recovering onto the glide slope. And in fact, if I'd been a bit more careful, I could have steered us on the localizer, which I'll do now. And then obviously we can capture the glide slope as we continue our descent. If I put it in heading, it would help. There we go. Coming nicely onto the glide slope, and so our target is going to be flap 10 at 3,000 feet. So I'm going to take the approach now just to make sure we are doing on localizer and glide slope, and I'm going to go flap 10 now. And a good target speed now would probably be about 180 knots. So 3,000 feet we're looking for, flaps 10 with 10 miles to go. And I think that's looking pretty good actually. The fact we're on the glide slope tells its own story. We've done all that. The power's now come up because we're on the glide slope. We've done all that as a very nicely arranged descent. No panics, no rush, totally in control of the situation. Here's a fictitious route that I've devised. Coming in at 10,000 feet again, you'll see the distance is coming up to 35 miles. The FMC wants to go down conveniently enough at our 35 mile gate, and let's see what happens if we suddenly get track shortening on this. So I'll let it run, and there's one or two tips I might be able to give you as we go through this. So let's suppose at this particular point we've just reached our top of descent point. ATC say it's all changed, turn left on a heading like that and descend to 3,000 feet. Well, the first thing I'll do is get things going, because we're already within our 20-mile range ring, and I know that that's a 6,000 foot target, so really I need to pull full speed brake. So do that first, get things going. Now there's a couple of things we can do with the FMC which might well be useful. The first one is a thing we call cleaning up the map. So go to Departures Arrivals, select the ILS again, and then go 6 right where it says DICME Intercept here. Select it and execute, and that will give you a straight in all the way to the runway, which is quite useful to do. Next thing, go to the VNAV page and select Off Path. Now if you want to know DICME, that's fine. Select the display on, and you've now got a couple of rings. The blue ring is the clean ring, no speed brake, and the white ring is the full speed brake ring. So I can see now that what I'm looking at is doable, even though I am 2,000 feet high on the VNAV profile. So at this stage we can start thinking about dirtying the aircraft up. So with regard to that, don't use the flaps as speed brakes. Bring the speed back. Don't worry about going a little bit high. And as the speed approaches the bug, select the next stage of flap like that. Once the flap's selected, I've selected flap 1, move down to the 1 bug, and within about 10 to 15 knots above the bug like that, select flap 5. And now select the flap 5 bug. Once you've got flap 5 set, you're in a very strong position, because the flaps, you've got all the leading edges out now, there's quite a lot of drag from the flaps. You're not taxing the system because you're coming down at minimum speeds, so that's good. And although I'm inside the white circle here, you can see actually that I'm recovering the profile as I go down. So the other thing you can do, if you're really desperate, is put the gear down. There's no need here. You'd have to be significantly higher than this before you put the gear down, and you'd have to be very careful about your speed control on that as well. But I'm looking fine, and DICME is about 10 miles out, so my 10-mile 3,000 foot profile would be appropriate. So I'm going to take a flap 10 mile sector like that at 180 knots and just let the aircraft come down. I'm just going to wind the range out a bit. You can see our range ring is showing we'll be at 3,000 feet just short of DICME, albeit with the speed brakes out. Now you can use speed brakes up to flap 10 like this fairly regularly. You shouldn't really be using the speed brakes with flap 20. So really all we've got to do now is watch how things progress, and hopefully we'll come nicely onto the glide slope at DICME and start to recover the approach. So that's basically it. Two things there. One was cleaning up the map, the other one was giving ourselves the off-path descent as a guide. And also I would say fly the aircraft first, and once you've got the aircraft heading in the right direction, then start putting numbers into the FMC. So I've just retracted the speed brakes, we're coming down to 3,000 feet, everything's sorted, we're ready for turn onto the ILS. So that's another way of what you might call mitigating a situation that was brought upon you. I hope you've enjoyed this video, and I look forward to seeing you again soon. Bye for now.